my name is Trisha Spanbauer. I'm from the Department of Earth and Atmospheric Sciences at the University of Nebraska-Lincoln.
I'm Trevor and I'm a PhD student in the School of Natural Resources and Department of Statistics at the University of Nebraska-Lincoln.
My collaborator and I met through the IGERT program. We came in at the same time and had similar interests in looking at how populations change over time. And he had some statistical indicators he was working with, and I had appropriate data sets for those statistical indicators, so it seemed like a natural progression for us to work together.
Working closely with people that have that intimate knowledge of those data sets is very important for someone like me who understands the computational methods, but the biology is a little bit weaker.
My research is focused on looking at long time series data collected from lake core material. Specifically, I look at a type of microalgae called diatoms. We collect diatom data by recovering sediment from lakes. We take subsections of that sediment and treat it and then look at it under a microscope. I will count up a diatom abundance and then we look at those changes in abundance over time. And for this particular project, we're looking at when we have known local extinctions of certain diatoms and whether or not we can apply these statistical indicators to these known extinctions and whether or not they correctly predict these local extinctions.
There's many populations that are currently declining relatively steadily. For example, bobwhite quail over the last 40 years have declined greatly throughout their range. And the worrisome part is that maybe at some level there will be a threshold that the population decreases rapidly to very low levels or even goes extinct locally. So identifying these thresholds before they are crossed is kind of critical to the management of these species. There's been rapid increase in the computing power in statistics recently, and this has allowed us to fit more realistic mathematical models to data sets. And these models are capable of bifurcating or showing the analogous to a threshold that we might see in real populations. However, these models are very complex and it's not really feasible to fit them to every data set of a fisheries or even a wildlife population. So we need something a little simpler. Statistical indicators may be the key here. They're just simple sample statistics that we would monitor in a population that may warn of these thresholds. May be very similar to monitoring the variance of a very volatile stock that would indicate of possible pathological underlying change. So the implications of our collaborative research are that we'll leave the scientific community with better tested tools that have been tested in the paleo data and current data sets.
Looking at the past can often give us important insight about the future.